Although scientists were learning to exploit electricity, they still didn't know what it actually was. But this question was being answered, with experiments looking into how electricity flowed through different materials. Back in the 1850s, one of Germany's great experimentalists and a talented glassblower, Heinrich Geissler, created these beautiful showpieces. Geissler pumped most of the air out of these intricate glass tubes and then had small amounts of other gases pumped in. He then passed an electrical current through them. They glowed with stunning colors, and the current flowing through the gas seemed tangible. Although they were designed purely for entertainment, over the next 50 years, scientists saw Geissler's tubes as a chance to study how electricity flowed. Efforts were made to pump more and more air out of the tubes. Could the electric current pass through nothingness, through the vacuum? This is a very rare flickbook film of the British scientist who created a vacuum good enough to answer that question. His name was William Crookes. Crookes created tubes like this. He pumped out as much of the air as he could so that it was as close to a vacuum as he could make it. Then, when he passed an electric current through the tube, he noticed a bright glow on the far end. A beam seemed to be shining through the tube and hitting the glass at the other end. It seemed at last we could see electricity. The beam became known as a cathode ray, and this tube was the forerunner of the cathode ray tube that was used in television sets for decades. Physicist J.J. Thomson discovered that these beams were made up of tiny negatively charged particles, and because they were carriers of electricity, they became known as electrons. Because the electrons only moved in one direction from the heated metal plate through the positively charged plate at the other end, they behaved in exactly the same way as Bose's semiconductor crystals. But whereas Bose's crystals were naturally temperamental, you had to find the right spot for them to work, these tubes could be manufactured consistently. They became known as valves, and they soon replaced crystals in radio sets everywhere. These discoveries would lead to an explosion of new technology.
Early 20th century electronics is all about what you can do with valves. So the radio industry is built on valves. Early television is built on valves. Early computers are built with valves. These are the things that you build the electronic world with.
Having discovered how to manipulate electrons flowing through a vacuum, scientists were now keen to understand how they could flow through other materials. But that meant understanding the things that made up materials, atoms. It was in the early years of the 20th century that we finally got a handle on exactly what atoms were made up of and how they behaved. And so what electricity actually was on the atomic scale. At the University of Manchester, Ernest Rutherford's team was studying the inner structure of the atom and producing a picture to describe what an atom looked like. This revelation would finally help explain some of the more puzzling features of electricity. By 1913, the picture of the atom was one in which you had a positively charged nucleus in the middle, surrounded by negatively charged orbiting electrons in patterns called shells. Each of these shells corresponded to an electron with a particular energy. Now, given an energy boost, an electron could jump from an inner shell to an outer one. And the energy had to be just right. If it wasn't enough, the electron wouldn't make the transition. And this boost was often temporary, because the electron would then drop back down again to its original shell. As it did this, it had to give off its excess energy by spitting out a photon. And the energy of each photon depended on its wavelength, or as we would perceive it, its color. Understanding the structure of atoms could now also explain nature's great electrical light shows. Just like Geisler's tubes, the type of gas the electricity passes through defines its color. Lightning has a blue tinge because of the nitrogen in our atmosphere. Higher in the atmosphere, the gases are different, and so is the color of the photons they produce, creating the spectacular auroras.